Now let us solve another numerical problem from engineering mechanics by Timosenko, D.H. Young, J.B. Rao and Sukumar Pati. I will be discussing, what I will be discussing is, one second, this one, 2.12, right? So let us begin with the statement of the problem is lengthy, but is as simple as your +1 physics, like how to resolve a vector into two rectangular components. In a level flight, the chord, I will explain you what is chord. This is the airfoil of an aeroplane. I mean the wing. This from this point to this point is called the chord. I will explain it in more detail. The chord AB of an aeroplane wing makes an angle alpha 5 degree with the horizontal. The chord of this, that is AB, this is your horizontal, is making an angle alpha. This is given as 5 degree, right? The resultant wind pressure on the wing, first is wind pressure on the wing, for such a condition is defined by lift and drag component. Now, from this point, the lift is upward, represented as L. The air drag, as the plane is moving forward, the drag is backward, given in this direction. And it is given that the lift is 6675 Newton and the drag is equal to 890 Newton, which are vertical and horizontal. The lift is vertical, the drag is horizontal, respectively, as shown. Resolve the force into rectangular components along x and y, coinciding with the chord AB and its normal, respectively. Now look, let me, before the discussion is very simple, but before I solve, let me explain certain aspects of aeronautical engineering. This point is called the leading edge of the wing, the point A. The point B is called the tailing edge of the wing. And here, as you can see, I have drawn another diagram for you. Here the wing diagram is slightly wrong. This upper portion has to be more convex. This lower portion has to be less convex, actually. So now look at as it is moving forward, the air, they split at the front end here. A part of the air moves above and a part of the air moves lower. This part is called the upper camber. This part is called the lower camber. The upper camber is more convex and the lower camber is less convex, so that the velocity of air on the top will be more and the velocity of air on the bottom and the lower camber will be less. Then we will apply Bernoulli's theorem. So to this side is drag, to this side is lift. Air pressure on this side, on the upper camber, pressure is reduced on the top and air pressure is increased underneath, that is below the lower camber. And the tail end, air accelerates downward. And O, the point O is the center of pressure, right? Now, these are certain things that you have to add. Then I have drawn another diagram for you. The same diagram. So this is your horizontal. This is your airfoil, the wing. This is your upper camber. This is your lower camber. which I have shown it here. This is your lower camber. This portion from here to here is less convex. This portion from here to here is more convex. So that on the top the velocity of air is more, and the bottom the velocity of air is less. Now, now as this and this angle, this is the chord line, and this is your horizontal. This angle is called the angle of attack, and the airplane path is to this side, and the relative velocity of the wind is to this side. Now this is a vector. Drag is the force. The value of d is given. Lift is another force. The value of L is given. We'll find out the component of L and the component of d, and this will be the resultant of the lift and the drag at the point O. Right. Now AB, from A to B, is called your chord length. Now what is a camber? The two surfaces of the airfoil are not symmetrical. Means the curvature of this and the curvature of this are not asymmetrical. The two surfaces of the airfoil are not symmetrical. And what is camber? The asymmetry between the two acting surfaces. This surface and this surface, the upper one is more convex, the lower one is less convex. That asymmetry is called camber, right? You might be asked a short question while facing certain viva examinations. Now, cambered wings lift more easily than flat wings in case of an aeroplane. Now, what you have to remember is, in Bernoulli's theorem that you studied in your +1 physics, pressure of a fluid. What is a fluid? Anything that flows, either a liquid or air, is lower when it is moving faster. If it is moving faster, pressure of a fluid is lower, P is less if velocity is more. Now, on this principle, therefore air pressure is more below the wing. So below the wing, that is below the lower camber, the air pressure will be more, and above the wing the air pressure will be less. So the plane will be lifted up. So similarly, air pressure is less above the wing, and this is your Bernoulli's theorem. If pressure is more, velocity is less. Or you can say if velocity is more, pressure is less. So let us discuss the problem. Very simple. I have again redrawn the diagram for you. What is given? The lift is given as 6675 Newton, lift force. The drag force is given as 890 Newton, the drag force. And the angle alpha is also given as 5 degree. Now look, this is your x-axis and this is your y-axis. So angle between x-axis and y-axis is 90. And the lift and the drag, they are also perpendicular. So this angle is common. So let this point is O. YOX, angle YOX is equal to 90 degree. Angle LOD is also 90 degree. Now what is common between these two angles? Is angle YOD. The common is angle YOD. So if you take out YOD from here, and if you take out YOD from here, this is 90, so whatever you are left will be equal. Therefore, this angle is equal to this angle. Since this is given as 5 degree, therefore this is also of 5 degree, right? Now, I have again redrawn the diagram here. This line is same thing as this line, the axis, x-axis. This is your y-axis. And here this is the drag force. the value of D is given. Here is the lift force, the value of L is given. This is 5 degree, this is 5 degree. So, taking this vector as the resultant, I construct a parallelogram. Look, this is a parallelogram. So, your OA and OB will be two components of L, where OA is along negative x-axis and OB is along positive y-axis. Similarly, considering OD, the drag force, this length, which represents the drag force, considering this as the resultant, if you construct a parallelogram, taking this as the diagonal, then your OC is equal to your horizontal component along positive x-axis, and OD is your vertical component of the drag force D along y-axis. Now it is simple. Therefore, you take sine theta in this triangle CDO and cross multiply, and again you take cos theta in triangle CDO, cos of this angle, then you cross multiply. Similarly, you take sine theta in triangle OBL and cross multiply. Similarly, you take cos theta, cos of this angle in triangle OBL and cross multiply to have all these values. So your OA will be L times sine 5, that comes out to be 581.76 Newton. Similarly, your OB by taking cos of this angle will be OB over OL. And if you cross multiply, you get OB is equal to L cos 5, that is equal to 6649.59 Newton. Similarly, in this triangle, in triangle OCD, now if you take cos of this angle, it will be OC over OD. And if you cross multiply, you get OC as D cos 5, that is 886.61 Newton. And if you take sine of this angle, that will be CD over OD. And if you cross multiply, you get OD is equal to D sine 5, that comes out to be 77.56 Newton. Now look at, if you look at the value of OC, this value is greater than this value. So, and both this force as well as this force, they are opposite to each other. So the resultant will be OC minus OA. So OC minus OA, just by subtracting this minus this, comes out to be 304.85 Newton along positive x-axis. This is more, this is less, so this minus this will be in the direction of this force, and OC is along positive x-axis. So OC minus OA, is 304.85 Newton along positive x-axis. So now, in case of OB and OD, both are in the same direction, OB and OD. And we know when two forces are in the same direction, they are just added. So the resultant of OB and OD, OB plus OD, just by adding, you get 6727.55 Newton along positive x-axis. Now, if you want to find the resultant lift and the drag, and then you can construct a diagram here. This is one force, this is another force. So it will be along this direction. Since this vector is perpendicular to this vector, so the resultant of the lift and the drag will be L square plus D square, square root of that comes out to be 6734.071 Newton, the resultant of the lift and the drag.